Hey folks, Bridges here. We are today we're gonna make some joints in Fusion. So this is shout out to Corey Duzan. He was my master teacher for IED, Introduction to Engineering Design, and he and John made this file available to our class to do some practice joints. So of course I use it with my class because this is a great exercise. So this is the different types of joints that you can create in Fusion, and we're going to put all these things together. So to do this, the first thing that we're going to do is first thing we're going to notice that this is an assembly, and you can tell that it's an assembly because there are 3 different cubes here all put together, and instead of being called cubes, they're actually called components, and you can see that our list of components goes down the browser list over here on the left. Okay, and while we're going down through here, you notice that if you click on one particular component, it will underline it to let you know which one it is. Right now, rigid base is selected, and I'm not sure why. You'll also notice that some of these components have a little push pin next to them, like the slider base. Matter of fact, it looks like it's all the bases have a push pin. What that means is they shouldn't be able to move around in space. The tops can, but the bases shouldn't be able to. And my rigid base here needs to be pinned so it can't move around in space. So I'm going to find my rigid base, I'm going to right click on it, and I'm going to pin that. It asks me, do you want to put this back in its original position, which is revert, or do you want to capture its new position? Doesn't really matter what we do. I'm going to revert. So now my rigid base is locked in place like the other bases. Great. So it's time to make some joints. We're going to go to, first I'm going to make sure nothing is selected. Press my escape key a couple times, and I'm going to go to assemble. Now on the assemble menu, we can see that joint is right here, and the shortcut key is just simply J. So it says you want to make a joint, and we do. The first thing I like to do is go to motion. And under the motion tab, it gives us 1, 2, 3, 4, 5, 6, 7 different joint types, all allowing different degrees of freedom. The first one I want to make is going to be the planar joint. So I'm going to choose planar. Now, a planar joint is like having a mouse, a computer mouse that's on a table or a mouse pad. So we'll go to position. After we've chosen planar, we'll go to position, and we're going to choose what we want is a surface and a point for each component. So I'm going to zoom in here, and I'm going to choose a surface. I'm going to hold control when I'm on that surface, and I'm going to choose the middle. Or I'm just, really honestly, it doesn't have to be the middle. So I'm going to choose any snap on that surface. Right there is fine. The next component is the planar base, and I'm going to choose any snap on that base. It gives you snaps around the edge or in the middle. And when I go back to motion, it specifies that we have degrees of freedom in the X and the Y axis. And we can move this just in case by pressing preview motion. And it allows it to rotate in the Z axis, and it allows it to slide in the X and Y axes. And when we say OK, we can test that out. And it stays on that surface without going up or down. Okay? We're going to continue making some joints here. Again, nothing is selected. I'm going to assemble, or I could just press the J key from here. Brings up my joint menu. And let's do the rigid block this time. Rigid means no degrees of freedom, no motion. I'm going to go from my motion tab, I'm going to select rigid. Sorry if my video just jumped. I chose rigid, and then I moved my camera to select the middle snap on my rigid block. It's the first component. I'll zoom back out, choose my rigid base, the center of that surface, that center snap, and it puts it in there. Now you could, if this was not the correct position, you could use offsets to put it in a different location, but we don't want to do that. We'll bring all of our offsets back to 0 because it already was pretty well centered. And once again, I can choose the motion tab and the preview motion and it shakes it around and says that these two are locked together, and when one moves, the other moves. So we'll say OK to that. Okay, we got a few more to go here. We'll go assemble, joint. This time let's do the slider base, and we want to choose the mating surfaces. First, let's choose sliding. Then we're going to choose the two mating surfaces that are going to touch each other. That would be the underside and the center here. And let's choose the top of the mating surface right here. And I'm going to just rotate just a little bit just to make sure that I've got the correct snap, and there we have it. Now this one's a tricky one. When I go to motion and preview here, it thinks that I want it to slide up to translate on the z-axis, which is not correct. We could try the other axes. Well, it's not the x, that leaves y, doesn't it? And that does look good. If for some reason that didn't look good, you could always choose a custom axis and then choose a parallel line. So a line parallel to the surface of travel that we want. I'm going to go back and make it the y-axis because it is in fact correct. And again, you can do offsets, or you could even do motion limits. Let's talk about motion limits for a second. A motion limit is what it sounds like. And you can always come back and edit one of your joints by right-clicking and edit joint. And under the motion tab, we can set some limits, which means it doesn't go down past a certain point. So let's set a minimum. Let's set a minimum. And when we select minimum, it defaults to 0, but I can move this little blue arrow right here, this motion here. And if I pull that back, it's going in the negative direction, you can see in my dialog box. And we're going to get it close right there. And look, that looks 1.9956 in the negative. We could probably safely assume that to be 2 if we want it to line up with the bottom of our piece. Oh, it went the wrong way. -2. And that's the limit of direction. The limit, it can go in this direction. Well, I can go ahead and place a maximum on there as well. A maximum of +2. Once again, you can move the arrows to get a maximum dimension. Looks like right around there. And that is right around 2. So I'll just say +2 for that one. And when I say OK, it now lets me go to that point only, and then also a maximum up there. That's great. Okay. One more thing while we're there. We can once again edit the joint, and we can cause it to rest. We can choose a resting point. We can make it rest on either the minimum or the maximum or anywhere in between. I'm going to make it rest on the minimum at a -2. And when I say OK, it doesn't like to go to the resting spot originally, but if we just try to move it once, it snaps back. So now no matter where I go and release, it snaps back to 0, or in this case, -2. I like that. Okay, the rest of this video, I'm just going to spend going through creating these joints. Assemble, joint. We're going to choose a cylindrical joint next. We're going to choose the outer surface of the cylinder and the inner surface of the, it wants me to choose a point, so I'll choose this point on the outer surface, and it wants me to line it up with something on this inner surface. I'm going to hold Control to keep that surface selected, and now choose this inner point right here. Okay. And it does allow me to, oh, well, that's not right, is it? I better go back and edit that joint, huh? And the motion type should be cylindrical, but the axis, okay, for the rotation should be actually something else. So the axis for the rotation, let's try them. That's not it. Let's try the Y. Okay, that looks like that's the correct rotational axis. So if I preview motion now, but I'm going around the wrong point. See, I didn't want to choose that point, did I? So I'll try this one all over again. I'm actually going to delete the joint, and I'm going to start all over. My mistake, y'all. And I can revert the position of that component by just reverting position here. There we go. So once again, joint, J key. Let's choose the motion to be cylindrical. This time let's choose the center of this top surface and the center of right there. Now when we go to motion, when we preview, that's the correct rotation. And then also the sliding, Well, it should slide along the same axis, and it does, so we're good. Just 3 more. Make them quick. Assemble, joint. One of the most common joint types is the Revolute. I'm going to choose the bottom center of the Revolute key. Oh, I forgot to say Revolute first, didn't I? And then the top center of the mating surface. And if it's ever the wrong way, if it ever flips the wrong way, you can unflip it right here. See? But ours looks good. And when you do that, you can turn it like a key. Okay. We're going to assemble a ball joint. So I'll choose ball. And on the ball, it wants us to actually select the center, the spherical center, so like the core of the Earth. We're choosing the outside surface, but we're going to choose the center of the ball. And then the same with the socket. This is the inside surface, but then the center is right there. And when we say OK, it does allow us to move that like a ball joint. Okay? If you want to see something really cool and disallow this is called interference when 2 bodies take up the same space. To cancel that, we can go to Assemble, and we can do something called Enable All Contact. Now be careful, if your computer is low on resources, this really likes to slow the computer down and freak it out. But what it's doing is it's now allowing 2 solids to not take up the same space, the same volume in space. I like that. If that's freaking your computer out and it's having trouble, you can go to Assemble and you can turn off that contact right there, disable contact. Okay, the last one, the pin slot. I honestly don't have a great way to do this one. I'm not super clear on it, so if you get that for bonus, great. Do give it a try. The way that I'm going to do it is use the pin slot, and then I'm going to choose the center of the top and the center of the arc. Okay. And that's probably, it wants me to edit the sliding portion here. So I'll go back and edit that joint. And I'll go to the motion. And for the sliding aspect, I'm going to choose a custom axis, which is this. And we'll say OK. Now, again, that's probably not perfect. I should probably turn on those contact sets to make it actually work. But for now, I'm going to say this video is good enough. Thanks for watching.